So in this video, I'm going to be showing how to make a first-person controller that uses the physics-based system in Unity. So FPS controllers are one of the most common systems and mechanics in video games, such as like Call of Duty and such. And so I just wanted to show a really quick tutorial on how to create the FPS controller. Now this FPS controller is the same as another video on my channel on how to create a physics-based FPS controller. However, that one goes into detail about how to really create this and what each little piece of information is and how it works and what it does. In this video, this is for users who know how to use Unity, know some maths, and in general just know how Unity works and just wants to know how to create an FPS controller. It's also for those who just really want to not really have to get all the details explained to them, and they more or less just want how to code it. So we're going to go ahead and create a new object. We're going to call it FPS Controller. And we're going to add a couple things. So we're going to add a capsule collider. And we're going to add a rigid body. So you should know that capsule colliders can handle collisions, and the rigid body also handles collisions. It will also be handling our gravity. So we're also going to change this to make it look like a default capsule in Unity. So if we go and create a capsule, we'll just remove the actual collider itself, because our upper head level, our parent level, is going to be handling this. And so if we click on this, we can go back, set it to 1. So I'm setting the pivot of my FPS controller to be actually at the very bottom. So it's actually at the very bottom here. And this object here is just the mesh. It's nothing more. It handles nothing. So what we need to create is a camera. And we're going to go ahead and mark it as the main camera. And we can just say FPS camera. So we'll reset this transform, and there's nothing in here, and then we're going to parent this under our FPS controller. So one other thing we're going to want to do is 1.75, makes it roughly around the head region. Turn gizmos on, roughly around the head region, so now we can kind of see how that looks. And so the next thing we're going to want to do is add a FPS script. So FPS controller, create and add. And let it open here. There it goes. Okay. And so what we're going to want to do is we're going to create a couple variables. So we're going to do one for the walk speed. We'll set that equal to 5. We'll have 1 for the run speed. 1 for the jump force. And then we're going to need to get a instance, or we're going to need to get a reference to our main cam. We're going to also need to control our main camera's rotation. So we're just going to do cam rotation. And then for later down the line, we're also going to need to clamp our camera rotation between two values. So min cam rotation is equal to 90. And max camera rotation is equal to -90. And I'll quickly show as to why it's 90 and -90. So if we quickly run over here, we can see that this value up here, if we go up, it's negative, and if we go down, it's positive. So that's why we're clamping it in that way. I'm just kind of thinking of it in terms of up is max and min is down. So that's just how I think of it. You could do this either way. In fact, whenever we do clamp it, you could literally just type -90 and 90 if that's how you wanted to do it. So we're also going to need a reference to our rigid body. So I'll grab that. And on awake, we're going to actually set up these values. So let's get component, rigid body, and then main cam is equal to camera.main. So now then, on update, we're going to want to set up our inputs. We're also going to need to say 2 more things in order to, 2 more booleans to set up when we want to use our jump input and to check whether we are grounded or not, because obviously if you're not grounded, you should not be able to jump. So now then, we're going to go ahead and get inputs, and we're also going to rotate on mouse movement. So I'll just get these two methods. So now I have two methods set up, and we're going to say inputs is equal to new vector2 of inputs.getAxes, no, not that, input.getAxes horizontal and input.getAxes vertical. So now I have those set up, and then we need to get, if our keyboard is pressed, get key down key code dot space, and if it is, we're going to say jump is equal to true. Now then, on rotate on mouse movement, we're going to want to actually rotate the character itself if we're horizontally moving our mouse, and if we're not horizontally moving our mouse, we want to rotate around the X direction on our camera. So once again, on the actual movement, we want to do around the Z axis, or around the Y axis for our actual player, and then for the FPS camera looking up and down, we want to just do, I was grabbing the whole thing there, but we just want to do around the X axis there. So now then, back to our code, we want to say mouse movement, and we can just say vector2 mouse movement is equal to new vector2 input dot get axes mouse x and input dot get axes mouse y. Now then, another thing to note is that these values are frame rate independent, so we do not have to multiply at any point by time.delta time. So anyways, transform dot rotation is equal to new, actually, so we're going to change, first we're going to change the rotation of our actual character. So we're going to say quaternion dot Euler, and then we're going to set up a new vector3 of 0f, 0f, and so now this middle one is the only axis we're going to be spinning around. So what we can do is we just say we want to grab our current rotation, so that's our current rotation, times our mouse movement dot x times some sort of mouse sensitivity, and we haven't set that up yet, so just I'll just set it to 7f. So times the mouse sensitivity. So since this is frame rate independent, it'll be really, really slow. So that's why we have to multiply by some sort of additional mouse sensitivity. And then this here is to grab our current rotation and then just add on to that. So that's how we're doing that here. Now then, we also want to modify our camera rotation, and I'm pointing to this because you can't use the main camera's already existing camera rotation, since the quaternion will actually change these values in order to help the actual rotation. I'll give a quick demonstration. So if I go all the way around, right, if I go to here, go like that, and then I try moving this around, these values are all changed now. And so now you see how this is going completely wonky, and then this is also going really messed up. So we don't want that to happen. So in order to do that, we're going to be getting the previous, we're just going to use this, and then we're going to, so I'll kind of show. So we're going to use this value to store what our X direction should be, and then change the local rotation of our camera rotation in order to modify just the x direction of the local variable or local rotation, and then that's how we're going to modify that. So we're going to go ahead and say that the mouse movement.y times the mouse sense. So this changes that. Also, this increments that. Also, another note about this is that Unity handles the actual direction seemingly inversely, so it's like upside down, so it actually has to be a negative here, so that it moves in the correct direction. And so I'll just do that, and then I want to clamp my camera rotation between my min and max. So I'm going to do cam rotation, and then I'm going to actually do max cam rotation, since that's our negative one here. If you don't like this, you could literally just type 90F and then comma 90F. However, I'm just going to do max cam rotation and then min camera rotation. So that is how I'm going to do it. It works the same if you just put negative 90 here and then 90 here. And then I'm going to do main cam dot transform dot local rotation. So this is the thing I was kind of mentioning earlier, is that the global rotation of the FPS camera changes with the player. So if I spin this guy 90 some degrees, we see that the player is facing the correct direction. So these frustum lines are working in the right direction. However, it says that my rotation is still 0, which is really, really good. That's exactly what we want to happen. However, it's not actually true. In the actual world space, we are now rotated whatever this is. And this all changes whenever this also rotates. So once this rotates up, you can kind of see how these values change. And so we want to use the local rotation and modify just that local rotation, so that everything else is just handled like by itself. This is also why Unity uses quaternions, because gimbal locking and other things are caused with just regular Euler angles. So that is why we use quaternions. So anyways, we're going to create a new vector 3 and change it from Euler to quaternion. And in order to do this, all we have to actually do is use our camera rotation, and then just like that. And so that actually works for everything that we needed. And as I said, use local rotation here, and then you can just use global rotation here. It doesn't really matter. But use local rotation here because it is in terms of the parent. So this is the actual camera. This is the parent. It's not in world space. It's actually under this actual controller, which you need it to be in order to actually follow along with the player. So you have to use local rotation in order to make sure you don't deal with really weird rotations. If you want to test this for yourself, just change this to rotation, and you can kind of see what I'm talking about with really weird rotations. So anyways, all of our setup is done. All of our checking is done. So I'm going to go ahead and now do our fixed update. So fixed update is actually where we're going to change our velocity and such. And using physics in Unity, to use physics with a controller for the player is actually very difficult. You're going to deal with a lot of sliding and stuff and a lot of just really weird feelings, because Unity uses drag and everything else in order to slow the rigid bodies down. So in order to maintain the snappy feeling that you get whenever you play first-person controller games, we're actually going to be straight up modifying the velocity vector so that it will change as the player moves, as the player presses inputs and is intending to move. So as such, we're going to go ahead and I'm going to start with just the movement, and then I'll add in the jumping in just a little bit. So vector 3 movement is equal to, we can actually just do transform dot forward. So our forward direction times inputs dot y, because we do the forward direction times the y, because that's my W and S. That's my forward and backwards. And then we're just going to go ahead and add this to transform.right, not rotation, transform.right times inputs.x. So that's our horizontal direction. Then we're going to say, this is just for sprinting and stuff. So input.get key, get key code.left shift. And if this is true, movement times equal to run speed. And then if we're not doing that, we're going to do movement times equal to walk speed. Go back. Okay. Now, so basically we have a unit vector for our movement. And so this actually just straight up describes our direction. It doesn't describe our actual movement vector. It just describes our direction. So then this here is what we're scaling our direction by in order to get an actual movement. So anyways, this little function here will tell us, will actually get us the values for our X and Z direction movement. It does not describe anything about our Y direction movement. And we'll get back to that in just a little bit, because Y direction is actually being handled by gravity. And then whenever we jump, we want to change that Y velocity in order to be our jump force. So along with all this movement stuff, we can just do rb.velocity is equal to new vector 3 movement.x movement.z. So I left this middle one blank because I wanted to explain a little bit. So we want our physics engine to handle our like gravity for us. And the reason we want to do this is that's kind of the whole reason we did a physics FPS controller in the first place, is because we kind of wanted to remove some of the responsibility from ourselves. So we want to actually have the gravity, which is already being applied, assuming this is checked, then this is already being applied here, the actual gravity. So we can just do rb.velocity, not that, rb.velocity.y, and this will just use whatever value we had in the previous update. So that is just perfectly fine. So now this should all work in terms of movement. Now we just need to add jumping. This is actually really easy to do. So I'm just going to say if jump, since we change in the get inputs, we change this to true. So if jump is true, we want to say rb.velocity is equal to new vector 3. And now, as we did here, we're basically going to do the exact opposite thing. So we're going to say rb.velocity.x jump force, and then rb.velocity.z. So we're basically just taking whatever was currently there, and we're just going to keep it as it is, and then we're just going to change the jump force. So if we're falling, we're now going to be jumping, which you technically won't be able to do, since you have to be grounded in order to jump. So if you're at 0, I guess, then it'll jump it up. And then we just want to say jump is equal to false. So now this should all work. One thing we have to do is we have to freeze the rotation of the character, or else physics will try to just push this guy over and he'll just fall over. So we're going to do that. And now if we run the game, we can just kind of move. We can run and sprint around. One thing we need to do obviously is lock the mouse into place. So I'll just quickly do that. So you can do this in the start or awake method. Do cursor dot lock state is equal to cursor lock mode dot locked, and then we'll do cursor dot visible is equal to false. So this will kind of make that all invisible, and also just lock it in terms of the game space. So last thing we need to do is we need to see if we're actually grounded. So the physics, the fixed update here, the physics update is currently handling all of our movement, but we don't really want that. I mean, we do actually want that, but we want to do some checks prior to that happening. So we're going to say private void handle movement, and then we're going to have this all happening. And then we're going to also have private void check ground. And so here now we're going to say check ground, and then we're going to handle movement. So all the physics checks are in here, and all the non-physics checks are up in the update, which is really how you should do it. So check ground, we're going to do raycast hit. And now in this video here, this hit is not really going to matter at the moment. However, in the next video I'm going to be doing is going to be actually using this hit in order to get angles from whatever ground we're touching or whatever ground we intend to move on. And then we're going to scale our movement vector down in terms of our angle in order to make sure we can only move up specific slopes, and we can not like overstep a certain level or slope or something like that. Because obviously you shouldn't be able to walk up a 75-degree angle, and so we're going to kind of prevent that using this hit information. So for now though, in just this video, we're just going to do physics.raycast, and then we're going to actually raycast. Another note about this is that if you don't anticipate on your video game ever having slopes, so if you're just gonna have walls, similar to like, can't think of like Portal games, I don't think they have very many slopes. But if they do have slopes, then don't quote me on that. But in those games, you're gonna have only just walls, so you don't really have to worry about this, because obviously a physics controller cannot walk up a wall, so a 90-degree angle doesn't matter. A 55-degree angle wouldn't matter. Like, you shouldn't be able to really walk up that if you don't want to. So we'll scale that in the next video. However, along with that, you can also, in the next video, I'm going to make it to where you can change what your value is. That scales it, so you can only walk up like, say, 75-degree angles, or you may only want to restrict it down to 45-degree angles, and so on and so forth. So we're going to do transform dot position plus vector 3 dot up times 0.05. Now the reason I'm doing this is because our actual character has the pivot at the bottom here. You can kind of see that. So that's its pivot, and that's its pivot. So if it's standing perfectly on the ground, at times you run the risk of hitting through the thing and never actually triggering the physics raycast. This isn't a problem if you change the pivot to actually be like shorter. So if we change this pivot here to be in the middle, so it'd just be 0 actually. If you just change the pivot to be there, then it won't matter. However, I like to have my pivots at the bottom. It's just kind of preference, so you can do it either way. But I'm gonna have my pivot at the bottom. So if you had yours in the middle, you'd have to make some adjustment to kind of fix this little portion here. However, I'll show how you can make that really, really simple for yourself. So this changes the position to be up a little bit, and I'll kind of show that in a little while as to why I'm doing that. And then we can say negative vector 3 dot up, and then I can say for 0.15f. Along with this, I should actually also show that you can do that. So we're going to do origin, direction, hit, and then max distance. And then is grounded is equal to true if we do hit, and if we don't hit, is grounded is equal to false. Yeah. So that should be everything. All except for I need to now do this. If is grounded, then we do this. So the reason I do it like this is that if we are grounded, we're going to want to change it. But if we're not grounded, we still want to turn off this is jump, because if we don't turn it off, if we actually do this, then once we hit the ground, then we'll jump, even if we're not pressing the jump button anymore. You can kind of show this for yourself if you would like. You can do is grounded here, and then just take this out of the actual statement. So this can just be like that. However, I'm just going to show it like this. So if you wanted to, you could show how, like, if you jump and then let go and you land on the ground, then you'll jump again and it'll look really strange. So maybe that's what you want, but that's not what I want. So I'm not gonna do it like that. Another reason I'm doing this check in here like this is because since these run at different increments, at times we could run this code here before we run the physics raycast to change the is grounded to true. So this is kind of more or less nitpicky stuff, but I like to make it more perfect, so that's how I'm going to do it like this. And basically what I mean is, if this would normally trigger, yet this runs first, this won't happen, and then this will happen, even though this won't trigger. So yeah, or vice versa, this will happen, but then this doesn't trigger because it doesn't detect it yet. So more or less, it's just to make sure this happens appropriately. So anyways, as I said, this will also be used in the next video, but for right now, it's just not going to be used. So yeah, that should be about everything, I believe. If we just kind of run the game and kind of see, I can't infinitely jump, and if I just move around, everything works perfectly. And I should also be able to jump on any sort of object here. Also, if you don't like how floaty your game feels, go under project settings, physics, and then I always like to change this to -18.5. I think that's just a good value. But I mean, you can just kind of change this to whatever you feel. So that feels significantly better. So yeah, that should be all for this video. If you guys like it, like and subscribe. Get ready for the next video, and yeah, I'll see you guys later.